Over 50% of the Earth's total carbon content is estimated to present in the form of a carbohydrate. Starches and sugars are common names for carbohydrate types. Glucose and fructose have the same formula of C6H12O6. They can appear as the open form in the aldehyde or ketose, or the closed cyclic hemiacetal form. Starches and sugars are common names for types of carbohydrates as well. Sugars consist of monosaccharides and disaccharides. The two most common monosaccharides are glucose and fructose, which is fruit sugar. Monosaccharides are the fundamental units or building blocks that make up all other carbohydrates. When two monosaccharide units are joined together, a disaccharide is formed. Examples of disaccharides include sucrose, or common table sugar, and lactose, which is milk sugar. Sucrose is harvested from sugarcane or sugar beets, like the sugar beet farms in the Thumb area of Michigan. Sucrose is made of glucose and fructose sugar units bonded together. Lactose is made of glucose and galactose sugar units bonded together. Galactose contains an aldehyde functional group similar to glucose. You'll be testing the carbohydrates of food products using the following tests: iodine, Benedict's, Barfid's, and Seliwanoff's. In the iodine test for polysaccharides, polysaccharides bind with iodine to form dark blue colored complexes. Mono and disaccharides do not bind with iodine. To do this test, you will add 1 ml of each sample, or a pea-sized amount, to each test tube. You will then add 2 to 3 drops of iodine solution and mix. A negative test does not have a color change, which indicates no polysaccharides. A positive test, or a dark blue color, indicates a starch or polysaccharide is present. A reducing sugar includes all monosaccharides and most disaccharides that have the hemiacetal form. Polysaccharides are non-reducing sugars. Monosaccharides can fluctuate between a ring open and a ring closed form. The ketone group and the aldehyde group in the ring open forms can be reduced using Benedict's test. To do this test, you will add 0.5 ml of each sample, or a pea-sized amount, to the test tube. You will then add 1.5 ml of Benedict's solution, and you will heat it in a water bath, and then cool the reaction mixture. A negative test is a blue solution, or no change. This indicates that there is no ketone or aldehyde present. A positive test, which can range from orange to green to brick red, indicates that a ketone or aldehyde is present. The Barfid's test will test for monosaccharides versus disaccharides. With different oxidizing agents, reducing disaccharides are considerably less reactive compared to monosaccharides. A reducing sugar can be classified as mono versus disaccharide by reacting them with Barfid's solution. Barfid's test only gives positive tests for monosaccharide reducing sugars. This test has a weaker oxidizing agent. To do this test, you will add 0.5 ml of each sample, or a pea-sized amount, to the test tube. Add 1.5 ml of Barfid's solution, heat it in a water bath for 5 minutes, and cool it down. A negative test is a blue solution, or no change, which indicates no monosaccharides are present. A positive test is a brick red or orange precipitate, which is the formation of copper oxide, and that indicates that a monosaccharide is present. In Seliwanoff's test for ketones, this test is used to distinguish between a monosaccharide that is an aldose or aldehyde, or a ketose, which contains a ketone. Glucose is an aldose, and fructose is a ketone. Ketoses will readily lose water when heated with 3 molar hydrochloric acid for 2 to 3 minutes. To do this test, you will add 0.5 ml of each sample, or a pea-sized amount, to the test tube. Add 5 ml of Seliwanoff's, heat in the water bath for 2 to 3 minutes, but no longer than 3 minutes, and then cool the reaction mixture. A negative test will be a blue-green solution, or a peach or yellow-colored solution. This indicates that an aldehyde is present or other functional groups. A positive test is a cherry red solution, which indicates that your sugar is a ketose or that a ketone is present.